what we are trying to do is like we have our CE versus QE value obtained from lab scale experiments, and then all we are trying to learn now is how to draw this line, something like operating line, say with a different slope. So this is minus V by M, minus V by M, minus V by M. In each of these case, the slope changes. So if my V by M is equal to minus 0.05, so if I have a curve like that, how do I draw a line that has a slope of minus 0.5? So that's the thing that we are trying to learn. So what we have to do is like we have our C0 value, and then we have our CU value. So let's stick to this. Let's take a CU value as a guideline for the moment. So, and let's assume that we have this. Let's if we have a equilibrium plot, say like from 0 to say 50 grams per liter, something, and then you have a curve like that. You can even take a random value, say like just put say like 0, 5, 10, 15, 20, 25, 30, 40, and 50. This ranges from 0 to 50, that matches with your x-axis in this type of isotherm. So by the way, CE by QE versus CE, this is, we call them as adsorption isotherm. I don't know whether I mentioned this word before or not. So because we perform this type of equilibrium experiment at constant temperature, so that's why we call this word isotherm. Isotherm means constant temperature. I'm not covering this part in detail because I know you already studied this adsorption. What you are learning new is this graphical method and some basics of adsorption. So if you have 0 to 50 in this type of isotherm, so just make a table 0, 5, 10 until 50, and then we know this slope value, say like at the moment our slope value is minus 0.05. So just put this value minus 0.05, minus 0.05, same value until here, and then we just multiply these values. So just multiply whatever the C value you here, C multiplied by minus V by M, minus V by M. So what to do? So if you multiply this value, or maybe I can do something, I can do this directly on the Excel sheet, but anyway I will do this one. So let's strike this. Maybe let's put it simple. So if you have an isotherm curve 0 to 50 grams per liter, maybe take any values, say 45 to 50, 45, 46, 47, 48, 49, 50. So just to follow this type of rules. I'm trying to find the easiest way to get the slope line. There are many ways. I'm trying to see which one will be more easier for you. C0, so we know slope value is some number, so minus 0.5 minus 0.5, so whole value minus 0.05. Just to multiply C multiplied by minus V by M. So let me do that in Excel sheet to see what's happening. 546. Sorry for going a bit slow because this is slightly tough, and 0.5. You need a bit of experience with Excel sheet or graph. You should have used graph paper before. Let's multiply these values. Okay, minus So if you multiply these values, you get just I'm using Excel in my at the moment. Minus 2.25, 2.3 minus 2.35 minus 2.4 minus 2.45 minus 2.5. So why we selected 45 to 50? So if I ask you in the exam, like our initial concentration is say 50 grams per liter, take something like 50, 49, 48, 47, 46, 45. Or if I ask it, we are starting from a solution that has an initial concentration of 40 grams per liter, you repeat the procedure starting from 40, 39, 38, 37, 36. So you must have at least 5 points. Yeah? And then you just multiply it by minus V by M, C multiplied by minus V by M. So something like that. So these are some cheap tricks. So just stick to these rules. This is not a bad one. It will work at the end of the day. So this value. So for the moment we know we are our objective is to calculate what is our CE and CQ. What is our CE and QE? Sorry, QE. Provided we started our experiment with a solution of initial concentration of 50 grams per liter and minus V by M ratio of minus 0.05. So what is this value? So we are trying to get a line whose slope should be equal to minus 0.05. And what you need to do now is like so since we know our initial concentration of the solution is 50 and we have some number here minus 2.5. So what you need to do is like you have to add some number to this column. So C0 multiplied by minus V by M plus some number that should make this value 0. So what is that number? All you need is to you just subtract or you just add 0.25. If you add 0.25, this value will become 0 and then you will get some number here in the top. So let's do that. So if you add this value, you will get 0 here, and here you will get 0.05, here you will get 0.1, here you will get 0.15, here you will get 0.2, and here you will get 0.25. So you get some number 0. So something like your 50, 0. So this is what you are targeting at the moment. So now what you need to plot is like you have to plot this value, follow the highlighter. This is not a bad technique, it will help you. So you plot this value in the x-axis and then you plot these values on the y-axis. That should give, we can have a curve of something like that. If we plot these two values, whatever the line you get, that will have a slope value of minus V by M, and that will hit somewhere at 50, 0. Oops, we didn't see this one. So what I mean is like so draw a line. So this is our equilibrium curve, CE versus QE, and then if you plot these values, whatever we calculated just now using some tricks, if you plot these two values, you will get something like that. And the line that connects these points, that should have a slope of minus V by M. Minus V by M. And if we extend this line somewhere around here, this particular point, so that will be your CE value. If you come down here, so whatever this line intersects on your equilibrium data, say let's say it intersects at point P, So the corresponding x value at point P, that's your CE, and the corresponding y value at point P, that's your QE. If the calculations are correct, if we go back to our problem where I showed the equilibrium data, if you did the calculations correct, and if you draw the something like if you draw the equilibrium curve, and then if you plot those values and draw the line that will cut on this equilibrium curve, and your CE value will be exactly equal to 44.27, and your QE value that will be exactly equal to 0.2865. So that's how you get this operating line. So that's one of the easiest way to draw the operating line. And say like imagine if you are starting with say some other experiment, say C0 again with 50 grams per liter of solution, and then this time your volume, let's say let's say the volume this time is what to fix now. Okay, let's say the volume is same 0.025 liters. This time mass is equal to 1 gram. So minus V by M will be equal to 0.025 divided by 1. That should be equal to minus 0.025 gram liters per gram. So now you can use the same procedure. So what we need to do is like if I want to calculate the CE and QE, all you need to do is to repeat the same procedure. Draw CE versus QE and then locate this 50 point, because we are dealing with the solution of initial concentration 50, 0, and then you should draw some line whose slope should be equal to minus 0.025 liters per gram. So how to get this value? Again, repeat the same procedure. So just select some random values, say 45, 46, 47, 48, 49, 50. So number closer to 50. So let's call this C, and then V by M, that's 0.025 minus 0.025 minus 0.025 minus 0.025. Take a product, C multiplied by minus V by M. Let me do this myself. 2 minus 0.025. So if we multiply, that value should be equal to minus 1.125 minus 1.15 minus 1.175 minus 1.2 minus 1.225 minus 1.25. So now so we have at 50 this value is equal to minus 1.25. so we have to make this value equal to 0. So how to do that? Just C multiplied by minus V by M plus 1.25. If you add 1.25 to this column, then you will get this value 0, and the remaining values will be equal to this values will be equal to 0.125, 0.1, 0.075, 0.05 and 0.025. So these are the values we will get. So all you need to do is like follow the highlighter now. This is very tough problem. I wish we have these live lectures. So all we are going to plot is like we are plotting this value, C value, and then these values. So if you plot them, if you plot these two values, so how to change the highlighter, follow the pink. If you plot this value, you will get some point. This will be this point 50 comma 0, that point will be here, and then you will get some values here, somewhere around here, and this slope will be equal to minus 0.025, and just extend this line until this line cuts your equilibrium line at somewhere here, at somewhere this point. So the corresponding, say let's call this as point P, so the corresponding x value at point P, that should be equal to CE, and the corresponding y value at point P, that should be equal to QE. So that's how you calculate. So you have only one equilibrium curve, and now we calculated what will be the expected equilibrium concentration or the amount adsorbed when you change the mass, of your adsorbent. And you can play with the, imagine if you do another experiment, say C0 is equal to 50 grams per liter. This time we can use 0.5 grams, 0.05 liters, and mass is equal to 1 gram, and in this case minus V by M will be equal to minus 0.5 liters. Okay, let's put 2 grams, maybe 3 grams. We use 3 grams of adsorbent, so this will be equal to minus 0.5 divided by 3. That should be equal to minus 0.05 divided by 3. That should be equal to minus 0.01667. So what we need is, like, we have to plot CE versus QE, and then locate this point where your initial concentration is. From there you draw a line. That slope should be equal to minus 0.1667, and then wherever this line cuts or intersects with your equilibrium curve, say let's at point P, the corresponding x value is your CE and the corresponding y value is your QE for this experiment. If you perform this experiment in the lab, at the end of equilibrium, this is the concentration you are going to get. So you are not doing an experiment, but you are predicting the experimental outcome using that simple equilibrium curve. I hope you all following this one. This is very tough, I think. So I will show, I'm explaining at the moment how to do this. I will also show this in the Excel sheet how to do. I will upload the video online, and probably just watch this video, and if you can't follow, we will make a live tutorial, so that time you can ask me some doubts. So C0 value, CE, I want you to learn this technique because you might expect this type of problem in your final exam. So if you plot, so from this value you can get CE and QE. So how to get this particular line? Again the same protocol. So just go see 50, say 45, 46, 47, 48, 49, 50, and then this time our minus V by M, that value is equal to minus 0.1667. so just minus 0.0167. you just multiply C multiplied by value, and this should be equal to 45. So this should be equal to minus 0.75 minus 0.7667 minus 0.7833 minus 0.8 minus 0.8167 and then minus 0.833. So we need to, so we are dealing with a solution of initial concentration 50. So we need to make this column equal to 0. So how to do that? So subtract the entire column here, C multiplied minus V by M minus or plus 833. When you add this 0.833, automatically you will get a value of 0 here. 0. So, and then you will get the value of 0.0833, 0.066, 0.05, 0.033, 0.166. This will be roughly 0. So if you plot, now if you plot, follow the highlighter, if you plot this C value on this column, you will get a slope whose value will be equal to this one, minus 0.01667. Yeah, I hope you all follow up to this point. This is very, I'm a bit worried. I hope you all follow this tricky business. So that's how we get the operating line. If you want, you can even change this number, say like, you can even make a bigger column, say 49, 44, 43, 42, and then you can plot. Now if you do an experiment, say we are dealing with a solution of C0 is equal to 40, say we are dealing with a solution of 40 grams per liter, and say volume of solution is 0.025 liters, mass is equal to say 1 gram. And so if I ask you what will be the amount adsorbed at equilibrium, so we need to you need to give me the value of CE and QE for this experimental condition, and you have this equilibrium curve CE versus QE. So all you need to do is so now we have 40 grams per liter, so take some number. You can range, you can even take 10 values, why not, say like 30, 31, 32, 33, go up to 40. Let's call this as C, and then you multiply this value by minus V by M. In this case, minus V by M is equal to minus 0.25, minus 0.25, and then you can multiply 30 multiplied by minus 0.025. So that should be equal to some number. So let me do this in the next page. We are doing this bit slow because this may be a bit tricky. It's okay to go slow. Minus V by M is same value, minus 0.025. So if we multiply it, C multiplied by minus V by M, so what this value will be equal to? These are heavy duty design problems, but it is good to learn this one. I think this is the only module you have the chance to learn this technique, because I know you know already what is an adsorption isotherm from your physical chemistry lecturers. So this is something we are doing the engineering side of. We are making use of those isotherms that you obtained in the lab. So this value will be minus 0.75, and then this will be minus 0.775, minus 0.8, minus 0.825, minus 0.875, minus 0.9, minus 0.925, minus 0.95. This is minus 1, minus point. I think I did something wrong. We'll read it again. Minus 0.75. Minus 0.8. Minus 0.875, minus 0.9, minus 0.925, minus 0.995. 975 minus 1, something like that. And then you have to make so at the moment we are dealing with the initial concentration of 40 grams per liter. So you have to convert this value, this column, to 0. So how to do that? So you take this column C multiplied by minus V by M, and you add a value of 1. So that should make this the corresponding Y value when C equal to 40, that will become 0. So this value will become 0. So just add this remaining value. So I hope you all can follow this one. Plus 1. I cannot recommend a book for this because I don't think this is available in any textbook. This is a very cool method that we use in the lab. And it's good if you are learning this. I'm going to upload in YouTube. Hope people from other universities, they might know about this technique. So something around and then once you have this value, so always remember you have to make this last value 0 if your initial concentration is 40. So you should get 40 zeros in this column. So if you plot CE versus QE and follow the highlighter, if you plot these values in the x-axis and if these values on the y-axis, you will get some point like that. And if you connect this line, the slope of that line should be equal to minus V by M, should be equal to minus 0.025. And then wherever this line intersect on the equilibrium curve, the corresponding x value is nothing but your CE value, and the corresponding QE value is not, so the corresponding value on the y-axis is nothing but your QE value. I hope you all follow this graphical method. So what I'm going to do is I will stop recording now, and then I will post this as a lecture 6 part 2, and then I will solve this problem straight in the Excel sheet, and then I will upload it like a tutorial. So in the exam, if I ask any problem like this, so try to use Excel sheet. Try to use it. It makes your life a bit faster, and then you can copy paste your Excel sheet and the answer in your copy paste the graph that you get in the Excel in your answer sheet, and then send it to me. I think this should be more than enough. I think. Hope you all can follow this. I hope it won't be a tough problem, I believe. And thanks for listening. Try to listen. One more thing I have to say, you must listen to this lecture one or twice, one time or more than one time, and try to understand how to use these graphical procedures. It's very tough. Yes, students will do mistake if they don't practice in the home. It's very difficult to solve this problem during the exam time. So you must know how to tackle this type of problem. If not, it will be very tough. It will be really tough. So thanks for listening.